Hi everyone, we're back with another physics paper today. This is 9702, paper 22, May June 2023. The time is 1 hour 15 minutes. So before we begin, let's take a look at the threshold. Here you go. For this particular paper, component 22, the maximum available raw mark is 60, and A was at 44, B was at 38, C was at 31, D was at 24, and E was at 16. So compared to the other two papers, paper 2.1 and paper 2.3, this was a bit easier, which is why A was at 44. So let's write that down. So out of a maximum mark of 60, A was at 44, B was at 38, C was at 31, D was at 24, and E was at 16. Alright, so if you want to calculate A star, the gap is around 6 to 7 marks, right? Look, 6, 7, 6, so it should be 6 to 7 marks here as well, so it should be 50 out of 60 was A star, so that was pretty hard to get. All right, comparatively. All right, so before we begin, I just want to say that if you guys like the videos, please do consider subscribing to the channel. It helps with the algorithm a lot, and please drop a like. And yeah, if you want more help and want access to all these solved papers for paper 2 and paper 1 from 2002 to 2023, physics paper 1, physics paper 2, paper 4, paper 5, as well as chemistry, biology. Then for math, you have P1, P3, mechanics, and statistics, and my notes for physics and chemistry. Do consider supporting me on Patreon. It's patreon.com/CAIE paper solved. I'll drop a link in the description. There are 3 tiers, one for just support, the other one for notes and paper solving requests, and you get access to ad-free videos as well as my notes and solved question papers, also problem solving sessions over text. And yeah, you can also support me with this tier, the ultimate learning experience, where you get access to one-on-one video chats where we solve your problems, access to some private videos for physics, chemistry, math, and bio, and your name in the credits on screen on all my YouTube videos, as well as priority for question paper solving requests, plus all of the stuff in the previous tiers. Okay, so without further ado, let's begin. Let's start. So the first question is define pressure. We know that pressure is actually force per unit area. Okay, so pressure is force per unit area, force by area. And you can also mention that the force has to be normal. The area normal to the force. So take this scenario for example. If you have a force that is at an angle, you guys have to take the component, like you guys got to take F cos theta divided by the area. Okay, you use the answer to H to show that the SI base units of pressure are kg meter to the power minus 1 s to the power minus 2. So as to this, P is equal to F by A. So we know that F is equal to MA, right? We know that F is equal to MA, which is kg ms minus 2. So that is kg ms minus 2 divided by area, which is meter square. So after simplification, we end up with kg meter to the power minus 1 second to the power minus 2. That is shown. Let's move on to the next one. A horizontal pipe has length L and a circular cross section of radius R. A liquid of density rho flows through the pipe. The mass m of liquid flowing through the pipe in time t is given by this equation, where P1 and P2 are the pressures at the ends of the pipe and K is a constant. Determine the SI base units of K. Fine. So here what we have to do is we need to make K the subject first. So if you do that, what do you end up with? K is equal to pi P2 minus P1 times R to the power 4 rho t divided by 8 ml. Okay, So now let's consider the units. Radius r, so it's going to be meters. Then length l, this is also going to be meters. Whoa, wait up. So pi does not have any units since it's a constant. And the difference in pressure, so the units for pressure are going to be this kg m minus 1 s minus 2. So this whole thing has a unit of kg m minus 1 s minus 2, because it's like 4 minus 2 pascals, right? 4 pascals minus 2 pascals, which is 2 pascals ultimately, right? Makes sense? So the unit will only come once, times r to the power 4, which is meter to the power 4, rho, density. Density equals to mass by volume, so it's kilograms into meter to the power minus 3, kg m minus 3, times t. What is t? Is it time? Yeah, time t, so it's going to be in seconds, actually seconds. So times seconds divided by 8 is a constant, so we ignore that. M is the mass, so it's going to be in kg, so that is kg, and L is the length, so it's going to be in meters. So we can get rid of a few things. For example, we can get rid of this, and after simplification, what do I end up with? I have 1 kg over here, so that is kg. Then for meter, I have meter to the power minus 1, meter to the power minus 3, which is meter to the power minus 4. And yeah, I also have meter to the power plus 4. So minus 4 plus 4 is 0. Okay, let me show another step for you guys. It's basically like this: meter to the power 4 times second to the power minus 2 and plus 1 over here. Minus 2 plus 1 is minus 1 times meter to the power minus 1. Okay, so you can get rid of this. Therefore, k is equal to kg meter minus 1 second minus 1. Okay, so this is my final answer: kg meter minus 1 second minus 1. All right, let's move on to the next part. An experiment is performed to determine the value of k by determining the values of the other quantities in the equation B. The values of L and R each have a percentage uncertainty of 2%. State and explain quantitatively which of these two quantities contributes more to the percentage uncertainty in the calculated value of k. So L and R both have a percentage uncertainty of 2%. So check this. L is only considered once, but R is considered 4 times. It's R to the power 4. So the percentage uncertainty of R will have greater impact, since it's going to be 2% times 4, which is 8% in total. That's the total impact. Okay, that's the total impact for R. So R has a greater impact on the percentage uncertainty. So let's write it like this. We can actually do the math. R contributes 4 times 2%, or you could say 8%, and L only contributes, and L contributes 2% only. So we can say that R contributes more to the percentage uncertainty. So R contributes more to the percentage uncertainty in K. Fine. That's good. So yeah, we're done with question number 1. Let's move on to question number 2. This you need to have memorized. It's taken directly from the syllabus. What is meant by the center of gravity of an object? So if we define it, it is defined as the point where all the weight, it is the point where all the weight of the object seems to act, or according to the syllabus, is taken to act. So this is what you guys need to have memorized. This is a very common question which you will face multiple times. The point where all the weight of the object is taken to act. 2 blocks are on a horizontal beam that is pivoted at its center of gravity, as shown in figure 2.1. Also guys, I plan to do the other physics papers soon as well. Paper 2.1, paper 2.3, as well as paper 1.1 and 1.3. This time around, I decided to do a paper, a variant from each paper, because you know, it helps everyone. And then depending on your exams for the October-November series, I plan to release more content. Okay, so keep an eye on the channel, subscribe to the channel, and please comment below for more paper requests. And also, please drop a like if the video helped you. A large block of weight 54 newtons is a distance of 0.45 meters from the pivot. A small block of weight 2.4 newtons is a distance of 0.95 meters from the pivot and a distance of 0.35 meters from the right hand end of the beam. The right hand end of the beam is connected to the ground by a string that is at an angle of 30 degrees to the horizontal, and the beam is in equilibrium. This is the most important point. So net force is equal to 0 and net moment is also equal to 0. Okay, so by taking moments about the pivot, calculate the tension T in the string. Fine. So you guys got to understand that T has two components. One is this vertical one, and the other is this horizontal one. So the horizontal one actually has no moment about the pivot because it's directly passing through the pivot. If any force passes through the pivot, it has no moment about that point. Okay. On the other hand, the vertical component does have a moment about the pivot since it is perpendicular. It isn't passing through the pivot basically. Okay. So what is the value of this component? It is T sine 30. Yeah. So let's begin. What's providing the clockwise? What are providing the clockwise moments? Which forces? This 2.4 Newton force over here as well as T sine 30. On the other hand, the anti-clockwise moment is being provided by this 54 Newton force over here. All right. So let's begin. The distance for the 54 Newton force is this. So we can say that 54 times, what was it? 0.45. 54 times 0.45 on that side is equal to the sum of the anti-clockwise moment is equal to the sum of the clockwise moment, which is 0.95 times 2.4. 2.4 times 0.95, that is one of them, as well as the other force, which is T sine 30. T sine 30 times the distance, which is 0.95 plus 0.35, which happens to be 1.3, I guess. 0.95 plus 0.35. Yeah, 1.3 times 1. Whoa, wait up. Times 1.3 meters. All right, so let's solve this. 54 times 0.45 minus 2.4 times 0.95. So 22.02 is equal to 1.3 times T sine 30 divided by 1.3 divided by sine 30. Oh, I have my calculator in radians. Make sure you have it in degrees, okay? Alright, so I'm getting a value of T is equal to 33.88 newtons. However, you have to take a look at the significant figures. All data I've used, all of them were given to 2SF. So I need to give my final answer to 2SF as well. So it's going to be 34 newtons to two significant figures. Okay, that's the important part. 34 newtons to two significant figures. Fine. The string is cut so that the beam is no longer in equilibrium. Fine. So we cut this now. Alright, that force doesn't exist anymore. Calculate the magnitude of the resultant moment about the pivot acting on the beam immediately after the string is cut. This is rather interesting. So, this moment from the string was keeping us in equilibrium. But now when you get rid of it, the anti-clockwise moment is now greater than the clockwise moment. By what amount exactly? By the amount that this moment was providing, the moment that the string was providing. Essentially, suppose this was 20 Newton meters, and maybe this was 16 Newton meters, and this was 4 Newton meters. So these two combined were keeping it in equilibrium. But now when you get rid of this, how much is the left hand side? How much is it bigger compared to the right hand side? 4, right? It's 20 minus 16, which is 4, or it's basically the difference, or it's basically the moment provided by the string. Essentially, that's the logic. So here you can just, you can do it in two ways. Either you can subtract these two, or you can just find out the value of this, right? Let me show you. So the resultant moment is actually equal to, you have the value of T now. which is 34 sine 30. What was the distance? Times 1.3, right? Times 1.3. This is one root, or the other root is you can subtract these two. 54 into 0.45. I think it was 22.02 or something. Yeah, 54 times 0.45 minus 2.4 times 0.95. Anti-clockwise minus clockwise. So yeah, answer into sine 30 to 1.3. This should be 1.3 over here, by the way. It is in fact 22.02, but I'm gonna give my answer to two significant figures, so it's 22 nanometers. All right, see if you guys get it. The beam in B now rotates when the string is cut, and the small block of weight 2.4 Newton is projected through the air. Okay, so when you cut this, the beam is gonna rotate like this, and this small box over here is gonna be, projected. Poor box. So it's just gonna fly like this. Okay, so it's basically gonna fly like this, and it's gonna form a projectile. So we have the end part of the projectile shown here. The beam rotates. Now it shows the last part of the path of the block before it hits the ground at point Y. At point X on the path, the block has a speed of 3.4 meters per second and is at a height of 1.8 meters above the horizontal ground. Okay. So at this point, it has a speed of 3.4 meters per second. Air resistance is negligible. Calculate the decrease in the gravitational potential energy of the block for its movement from x to y. So change in GPE, you guys know the drill. You know that the change in energy or the change in GPE is essentially mg del h. Okay, so what can we do? Or you could just go for weight times del h, same thing. All right, so let's go for it. We have the weight already, that's why they preferred that formula. Mg is weight, so that is 2.4 times the change in height as it falls through the distance, which is 2.4 times 1.8. That gives us a value of 4.32, but we are going to give a 2SF answer, which is 4.3 joules. Yeah, so 4.3 joules. Fine. Use your answer to C1 and the conservation of energy to determine the kinetic energy of the uh, you know block at Y. So basically, air resistance is negligible, so no energy is lost. So the GP that I lose at point X is equal to the gain in KE at point Y. But the block already has some initial KE, so I'm going to find that out. So initial kinetic energy is equal to half mv square, which is half times, if you want to find out the mass, you know that mg is equal to 2.4, so the mass is going to be 2.4 by g, or by 9.81. Yeah, so the mass is going to be 2.4 by 9.81 times v square. What was the initial speed? It was 3.4, right? Where was that mentioned? Here. So that is 3.4. So let's do this. 2.4 by 9.81 times 3.4 square times 0.5, which gives me a value of 1.414. Now finally, this is the initial KE, or the KE at X. Now if you want to find out the final kinetic energy, or we could say the kinetic energy at Y, which is basically it is equal to the initial K that we had as well as the loss in GPE that is going to be converted into kinetic energy. So 1.414 plus 4.3, which gives us an answer of 5.71, which we round off to two significant figures, 5.7 joules. Fine? Does that make sense? Or you could go for the M1 approach. I want to show you that as well. What is the M1 approach? The one we do in mechanics, basically. You could say that the final KE is equal to the initial KE plus the loss in GP. You could do it directly. That also works, okay? And using that, you could find out the final answer. That also works, alright? It's up to you guys how you want to do it. Like here, you could get rid of the mass on each side. So we end up with half times v square is equal to half times 3.4 square plus 9.81 into the height 1.8. So yeah, if you solve this, you're going to end up with v, which happens to be 6.85. And following that, you can get the final k, half into m into 6.85 square. That also gives you an answer of 5.7. Okay, so it's up to you guys what you want to do. State the variation, if any, in the direction of the acceleration of the block as it moves from x to y. So this was actually a trick question. Honestly, since air resistance is negligible, the only force that the block feels is weight, which is felt vertically downwards. So the answer is there is no variation in the direction of the acceleration. As why? Because acceleration is always directed vertically downwards because there is no resistive force. Yeah, that's the logic. It's a really important question. Okay, it's important that you understand projectile motion. You can check out my other videos if you don't understand. The block passes point x at time tx and arrives at point y at time ty. On figure 9.3, sketch a graph to show the variation of the magnitude of the horizontal component of the velocity of the block with time from tx to ty. So here's the thing, for a projectile, remember guys, this is also a trick question. Horizontal velocity never changes, it remains constant. But the vertical velocity actually goes from a positive value to a negative value throughout the journey. Because, the block, maybe it goes like this. So till its maximum point, it has a positive value maybe of velocity, the vertical component. But after this point onwards, it turns into a negative value. Okay. So basically, this was also a trick question. It is basically going to be a straight horizontal line. Okay, it's essentially a straight horizontal line. That's it. That doesn't change with time. It's constant. So you could draw this better with your scale. I can also show you using this, something like this basically. Okay, so yeah, that's it. And if they say vertical component, then it would just be a straight line with positive gradient or negative gradient. Depends on which side was held positive. Suppose if downwards was negative, then it would be a straight line with, it would be below the x-axis actually. Because, it would be below the x-axis. It would be something like this, okay? But since, it's maybe like for if nothing is mentioned, just assume that going to the right is positive and going down is negative. Okay, anyway, let's move on to question number 3. So how many do we have in this question in total? So there's a total of 5 questions, so pretty straightforward. We're going to be done in 30 minutes. A block is pulled. Wait, there might be more actually below this. Oh yeah, we have 6 7, sorry, there are a lot of blank pages in between. So a block is pulled by a force x in a straight line along a rough horizontal surface as shown in figure 3.1. Assume that the total resistive force opposing the motion of the block is 0.80 at all speeds of the block. Okay. Define force. So this is a really common question that you guys are going to face. Force is defined as the rate of change of momentum. Rate of change of momentum. You need to know this. You cannot forget this, okay? Okay, so determine the change in momentum of the block from time 0 to time 3. Fine. So we know that, force is equal to del P by del T. So the change in momentum is equal to F into del T, where F is the really important resultant force. Fine. So let's take a look at the motion from time 0 to 3 seconds. What is the value of force? It is 1.4 newtons. This is the forward force, 1.4 newtons. Now, what is the backward force? It is always 0.80 regardless of the speed. So the resultant force is actually going to be 1.4 minus 0.80. That's the thing that you need to understand. It is the change in momentum is typically the area under the graph, which should be 1.4 times zero point 0.3. But given that the graph is for resultant force, but since x isn't the resultant force but rather the forward force, you need to find out the resultant force beforehand. Okay, so let's do that. The change in momentum is equal to resultant force into change in time. The resultant force is actually equal to, I just taught you, it's 1.4 minus 0.80 times the time 3 seconds, which gives us an answer of 1.8 kgms minus 1. Okay, so essentially what happened was, 1.4 minus zero point 0.8, which is 0.6. After you subtract that, you end up with 0.6, 0.6. So it is basically this part, this area under the graph is the change in momentum. Okay, now let's move on to the next one. So always remember to find out the resultant force first, then multiply with the change in time. Describe and explain the motion of the block between time 3 and 6. This was clearly a trick question, because look, after 3 seconds, what is your velocity? It is zero point 0.8. Your forward force is zero point 0.8, and the backward force is also zero point 0.8. So what is the resultant force? 0.80 minus zero point 0, which is 0. So let's write this down, that the resultant force on the block is 0 now. As a result, there is no acceleration, so velocity remains constant. So velocity is constant. Okay, see if that's fine. Force X produces a total power of 2 watts when moving the block between time 3 and time 6. Calculate the distance moved by the block during this time interval. So force X produces a total power of this. When you move at constant velocity, you can apply another formula, which is P is equal to Fv. This can only be used when you are moving at constant velocity. Okay, because if velocity changes, then the value of power will change and the value of force will change. So using this, we can actually find this out. 2.0 is equal to this force over here is the driving force X, not the resultant force. The F here is the driving force, not the resultant force. So between time 3 and 6, what was our velocity? It was 0.80, right? So 0.80 times v, so v is equal to 2 by 0.80, which is 2 by 0.8, 2.5. And we already stated that the velocity is constant. So for 3 seconds, what is our distance moved? We can use the formula S equals to Vt. So the distance is equal to 2.5 times 3 seconds, which is 7.5 meters. Yeah, all good. Now, the block is at rest at time t is equal to 0. On figure 3.3, sketch a graph to show the variation of the momentum of the block with time t from t 0 to 6 seconds. Numerical values of momentum are not required. Interesting. So the thing is, we need to know that from 3 to 6 onwards, velocity is constant and mass is also constant. So P must also be constant from 3 to 6. Okay. So what was the change in momentum? From time 0 to 3 seconds, it was 1.8 according to my working. So even though they don't want numerical values, why don't I just give some? Okay, so this is 1.0 and this is 2.0. Okay, and the unit is kg meter second minus 1. So 1.8 should be over here, 1.8. So in the first 3 seconds, I gain a momentum of 1.8 actually. It should be a straight line like this, straight up. So hard to draw a line on OneNote. Wait. Fine. Okay, so what's the next section? Afterwards, we move at constant velocity. So our momentum also remains constant till 6. This is the graph. So from 0 to 3, according to the Mark scheme, it should be an upward sloping straight line from the origin, since we started from rest at time 0. So we had 0 momentum, and then a horizontal line at non-zero value of momentum with no step change in momentum at 3. But my one is with an accurate representation with the quantitative values, okay? Let's move on. Question number 4. We have 4 questions left. A spring is suspended from a fixed point at one end. The spring is extended by a vertical force applied to the other end. The variation of the applied force F with the length L of the spring is shown. Now for the spring, state the name of the law that gives the relationship between force and extension. So we know that force is proportional to extension until the limit of proportionality. So this is called Hooke's law. You guys know that from O levels. And is determine the spring constant in newtons per meter. So remember that you need to check whether if it's f against x, that's the first thing, so the gradient will be the answer, and you need to check the unit, whether it's in meters or centimeters, and what unit they want. They want it in newton per meter, although the unit over here is in centimeters. Now let's start from 8, and yeah, this is the length of the spring, not the extension. X is the extension, so we need to take the extension. So why don't you pick any value? For example, you can pick the end, or you can pick this midpoint. The answer will always work. So why don't we take the end? Okay, you could also take this point, 16.6. So what is the extension? If I take the end, it's 24 minus 8, which is 16 centimeters or 0.16 meters, and the force applied is 12 newtons. All right, so we know that F is equal to kx, or k is equal to f by x, which is the gradient. Fine. Now the force applied, I told you it's 12 newtons, and the extension is 24 minus 8. 24 minus 8 into 10 to the power minus 2. So k is equal to 12 divided by 0.16. So 12 by answer gives me an answer of 75. K is equal to 75 Newton per meter. Really important sum. It would also work for other values, like if you took 16 and 8, you would take 6 over here. So it would be 6 divided by 0.08 then. So try doing that. 6 by 0.08 gives you an answer of 75 as well, okay? That works. Determine the elastic potential energy when F equals to 6. Exactly what they wanted. When F equals to 6, find out the elastic potential energy. You guys know that elastic potential energy is the area under the graph, which is half Fx or half kx squared. So half Fx is simply going to be half into 6 times the extension 8 into 10 power minus 2. So let's do that. Let's write down that the energy is equal to half Fx. So I'm just going to input the values. Half times 6.0 times the extension, which was 8, right? It is 16 minus 8, which is 8.0 into 10 to the power minus 2. Or this is how they wrote it, 0.080. So 0.5 times 6.080. We get a value of 0.24 joules, alright? 0.24 joules, and that is our answer. You could also write that it's the area under the graph, or you could also write half kx square area under the graph. All of them give the same answer, okay? It's up to you guys what you want to go. You have multiple routes open, okay? Let's move on to question number 5 then. We have 3 questions left. A progressive wave travels through a medium. The wave causes a particle of the medium to vibrate along a line P. The energy of the wave propagates along a line Q. Compare the directions of lines P and Q if the wave is a transverse wave. So we know that energy is propagated from left to right according to this question, or right to left. Now for a transverse wave, the direction of oscillation of the particles is perpendicular, right, to the direction of energy propagation. So here we write they are perpendicular, or you could just write perpendicular. That is also fine. Just perpendicular is fine. And for longitudinal waves, you can just write that they are parallel. Okay, they are parallel. All right. The tube is closed at one end, a loudspeaker is placed near the other end of the tube as shown in figure 5.1. The loudspeaker emits sound of frequency 1.7 kHz. The speed of sound in the air in the tube is 340 meters per second. A station wave is formed with an antinode A at the open end of the tube. There is only one other antinode inside the tube as shown. So this is what the picture looks like. So you have an antinode here. At the closed end, okay, this is the rule. At the closed end, you must have a node. So the other node must be over here. So let's try to draw a figure. This is what the diagram looks like. There you go. And the nodes are over here. Node over here. Let me use another color. Node over here. Node over here. Okay. So the loudspeaker emits the sound of this 1.7 kilohertz. The speed is this. Determine the wavelength of the sound. So here's the thing. We know that for any wave, v is equal to f lambda. So 340 is equal to frequency 1700 times lambda. So 340 by 1700 is 0.20. Since my minimum significant figure is 2SF, you can't write 0.2 meters. You'll lose marks then. You have to write 0.20 meters, okay? That's what you need to keep in mind. No one significant figure answers are allowed. The length L of the tube. Okay. So what do we have here? Antinode to node, which is lambda by 4, and then node to node, which is lambda by 2. So in total, if you add them up, you get 3 lambda by 4. So we can say that L is equal to 3 lambda by 4. So L is equal to 3 by 4 into 0.20. So 3 by 4 into answer gives you a value of, wait up, 3 by 4 into 0.2, that is 0.15. L is actually equal to 0.15 meters. Interesting. 0.15 meters. That's the value of L. Now let's move on to the next one. So always remember, this is the trick. Antinode to antinode is lambda by 4. Same goes for node to node, and antinode to node or node to antinode. Sorry, I messed up here. Antinode to antinode or node to node, that value is always going to be lambda by 2. This one over here is lambda by 2. And antinode to node is lambda by 4. Alright, this is the thing that you need to have memorized. The maximum wavelength of the sound from the loudspeaker that can produce a stationary wave in the tube. Okay, so let's take a look at this. We know that the patterns for one end open and another end closed are like this. The first pattern is like this. Let me draw a bigger opening. So this is the first pattern. This is called the first resonance. This is the first pattern where we have an antinode here and a node over here. Okay, and then as you keep on going, wait up, you're going to have another pattern where it's like this. You have a node over here, antinode over here, and then a node over here again. So the one I drew in this diagram particularly, something like this. Okay, there you go. And then if you keep on going, you get more patterns, like, you know, maybe something like this. Another loop in between, and then another loop in between, and the node ends at one end. Something like this, basically. So as you keep on increasing, what happens to the frequency? This is f naught, this is 3f naught, and this is 5f naught. So as you keep on increasing this pattern, the frequency increases, and similarly throughout this trend, okay, frequency increases but lambda decreases. So since they want the one with maximum, this is the key point, maximum wavelength, we need the first pattern, this one over here. So the length of the tube will remain unchanged. The length will remain the same at 0.15 meters. However, the distance will be from one antinode to node, which is lambda by 4. So can I write this, that L is equal to lambda by 4 now? So lambda is equal to be 4 times L, which is 4 times 0.15, which is 0.60. See if you guys get it. Really important question, and do comment below if you need another explanation, but I tried to simplify it as much as possible. Basically, the first pattern has the highest wavelength, and I drew it, and afterwards I just show you the working that anterior to node is lambda by 4. The length remains unchanged, so I exploited that fact to find out the new wavelength. Okay, moving on to the next part, part C, the new addition to the syllabus. We actually have 8 questions in this paper. It's quite big, apparently. Two polarizing filters are arranged so that this is a new addition to the syllabus, Mal's law. Two polarizing filters are arranged so that their planes are vertical and parallel. The first filter has its transmission axis at an angle of 35 degrees to the vertical, sorry, and the second filter has its transmission axis at an angle of alpha to the vertical as shown. Okay, so the first one is an angle of 35 to the vertical, and the second one is an angle of alpha to the vertical. Fine. So we initially have a light beam with intensity 8.5. Angle alpha is greater than 35 but less than 90. Okay, it is greater than 35 but less than 90. Fine. So initially we have vertically polarized light of intensity this. So initially we have light which is along this plane over here. We have light which is along this plane. So let me copy this. There you go. You have light like this which is traveling towards the first polarizing filter. So after it goes through it, show the intensity of light transmitted by the first filter is this. So Mal's law states that, what is Mal's law? I is equal to I naught cos square theta. So I is equal to 8.5 cos square, what's theta? 35 degrees. Let's do this. So cos 35 square into 8.5, that gives me a value of, this I over here is 5.7 to two significant figures, which does match. It does match. So this over here is my new light. However, you guys gotta understand that it is actually not vertical anymore after it passes through a filter. Remember this, guys. After light passes through a filter, through a transmission axis, it actually changes a bit. It changes a bit. Now it's no longer vertical, but rather it is at an angle of 35 degrees. Okay, it is at an angle of 35 degrees to the vertical. Okay, it is no longer vertical. So when you do the math, you can't consider alpha because alpha is the angle with the vertical. For example, if alpha is 55 degrees, when you input it in I, you can't consider 55 degrees. You can't consider the angle with the vertical anymore. You have to consider the angle with the current transmission axis, for example, with the current direction of motion right now. For example, if it's like this, if it's like this, I'm traveling at 35 degrees to the vertical and the transmission axis of alpha is at 55 degrees to the vertical. I need to take the difference of 20 degrees. I need to take this difference over here to find out the value of intensity at the end. Okay, so that's what you need to know for Mal's law. So we are going to write this again. I is equal to I naught cos square theta. So the final I, which is 5.2, I know that the final I is given. And we have the I at the middle point, which is, 5.7, I think. It's 5.7. So that's the initial one, 5.7. Cos square, it's actually going to be, this theta. This theta is basically alpha minus, okay, this theta is actually alpha minus 35 degree. We're going to find it out later. All right, so let's do this. 5.2 divided by 5.7 root over answer, and finally cos inverse answer. 5.2 by 5.7 equals to cos square theta. Cos theta equals to root over this 5.2 by 5.7. And finally, cos inverse answer gives you an answer of 17 degrees. Not Celsius, my bad. 17 degrees. All right. Now, we know that this theta is actually equal to alpha minus 35 degree. So if you want to find out alpha, what do you need to do? It's theta plus 35 degree, which is 17 plus 35 degree, which gives you a final answer of 52 degrees. So rather complicated sum. First time I've seen this. Food for thought. This is important that you guys get this. Rather complicated sum. Okay. It's important that you figure this out. Hopefully I could clarify. If you need more clarification, please comment below. Let's move on to question number 6 now. 6, 7, 8 left. The current in a filament lamp decreases. State how the resistance of the lamp changes. So, you know the IV characteristic of a filament lamp, it looks like this. As voltage or current increases, temperature increases, resistance increases. So here the opposite will happen, right? The temperature, since current decreases, the temperature decreases. So we could say that, so resistance also decreases, and if current increases, then the opposite happens, right? Now we have a cylindrical wire that has length L and resistance R. The total number of free electrons, charge carriers contained in the volume of the wire is N. Each free electron has charge E. The potential difference between the ends of the wire is V. Determine expressions in terms of sum or all the symbols E, L, N, R, and V for the current in the wire. By the way, we are gonna hit 10,000 subscribers soon. This video is probably gonna be uploaded when I've already reached 10,000 subscribers. Shout out to you guys for all the support. It has been like 1.5 years since I've started the channel, and it has been a great journey for now. And yeah, I've actually expanded the channel to O levels content. Now I'm gonna be in charge of doing AS and A2 content while I'm hiring other people to do O levels content. I might be expanding to IGCSE as well as A level commerce, O level commerce subjects too soon. But I need support from you guys, and you would do me a huge favor by actually recommending my channel to juniors. For if you recommend my O levels content to them, that would help increase reach. So please try to help me in that way. And yeah, shares would help, likes would help, anything would help, honestly. Anyway, let's continue with the paper. A cylindrical wire has length L and resistance R. The total number of free electrons, charge carriers contained in the volume of the wire is N. Each free electron has charge E. The potential difference between the ends of the wire is V. Okay, so the first one is pretty simple. Determine an expression for the current in the wire. We know that in terms of V and R, right? We know that V is equal to IR, so current is equal to V by R actually. So it's simply V divided by R, that's it. Now, the average drift speed of the electrons. This is really important. So let's do this. We know that according to the equation, it's I is equal to NAVQ, where N is the number density of charge carriers, A is the area through which the wire is passing, V is the drift velocity of electrons, and Q is essentially the charge of each electron. Now, small n is the number density of charge carriers, while capital N is the total number of charge carriers. And we don't have volume. So look at this. Small n is actually equal to the total number of electrons divided by the volume of the prism through which the charge is passing. So volume for a prism is area times length. So this is the formula for small n, number density of charge carriers. So I'm gonna input V by R in the place of I. V by R is equal to capital N by AL times area times small v times, in the place of Q, I'm gonna input E because that's what they wanted us to do, right? So let's do that, times E. Now I need to make V the subject. Before that, I can get rid of these. So V is actually equal to, small v is equal to V times L divided by NRE. V times L divided by, after cross multiplication, NRE. VL divided by NRE. Okay, if you guys want one more step to clarify things, V by R is equal to NVE by L. So afterwards, V is equal to V times L divided by NRE. That is my answer. Okay. So I've used two formulas. One being I is equal to NAVQ, and the other being small n is equal to capital N. The total number of electrons divided by volume. It's the number of electrons per unit volume of the conductor. Average time taken for a free electron to move along the full length of the wire. So we know that the drift velocity is the average speed. We know that drift velocity is equal to the total distance. Okay, velocity equals to distance by time taken, or time is equal to distance by speed. So the time taken is equal to the distance by the speed, which is equal to the distance or the length of the wire L divided by VL by NRE. So you can actually get rid of these L's, and after reciprocal you end up with NRE by V. This is our final answer. NR small e, my bad. NRE by V. That is it. NRE by V. Or RNE by V according to them. Same thing though. Okay? So hopefully you guys got it. Quite a different question, I would say. By the way, there was an alternate way in which we could do part 2. So for velocity, you could just go for velocity equals to length by time taken. Now you know that Q is equal to IT, right? So time is equal to Q by I. So you could input V is equal to L divided by Q by I. So you'd ultimately end up with um, V is equal to Li by Q. Now you know that L is L and I is V by R, while Q, the total charge Q, is actually equal to the number of electrons multiplied by the charge of each electron, Ne. So afterwards, we'd end up with LV divided by NRE. Same thing, okay? That is one way for part 2, alternate route, the more you know. I would honestly go for the one on the left though. And for this last one, for part 3, there is also another route. You know that Q is equal to IT. So time is just, Q by I. So um, you know that Q, I just taught you Q is Ne and I is V by R. So after reciprocal, you end up with RNE by V. Same answer, okay? Moving on to question number 7. A battery of electromotive force 9 volts and negligible internal resistance is connected to an LDR and a fixed resistor. The LDR has 1800 ohms and the resistor has 1200 ohms respectively. Now, since this is a series circuit and they have the same current flowing through them, I can use the potential divider to find the voltage across the LDR. So it's going to be pretty simple. We can simply write that, 1800 divided by the resistance of the component, the resistance of the component, right? Like if we have a component that is of priority, I want to find out the voltage of a certain component, then you have to take that resistance in the numerator divided by the total resistance in the circuit, 1800 plus 1200. So that is actually equal to the ratio, right, of the voltage that is taken up by this particular resistor, which is unknown, divided by the EMF of the circuit. So in a simplified format, this can be written as 1800 by 3000 after cross multiplication into 9 is equal to V. So 1800 by 3000 into 9. So V is equal to 5.4 volts. This is really important, okay? So please use the potential divider. There is another route. You could find out the current, voltage, EMF by 3000, which gives you a value of, how much is it? 3.0 into 10 power minus 3 amps. And then you could go for V is equal to IR, which is the lame route. Don't do that. You guys are better than this. Just use the potential divider, okay? That's better. The circuit is now modified by adding a uniform resistance wire XY and a galvanometer as shown in figure 7.2. The length of the wire is 1.2 meters. The movable connections that is positioned on the wire XY so that the galvanometer reading is 0. This is important. In a potentiometer, what is it used for? It's used to compare EMFs. So since the galvanometer reading is 0 right now, what does that mean? This part has the same voltage as this part, and this part also has the same voltage as this one over here. They match, which is why the galvanometer reading is 0. Calculate the length xz along the resistance wire. We have the same conditions as before. It has the same resistance. So since this was taking 5.4 volts, so the one on the right should be taking 9 minus 5.4, which is 3.6 volts. Now they want us to find out the length of xz, this length over here, xz. So the total length is 1.2 meters. Fine. So length and resistance have the same impact. Okay. For example, you know how I did R divided by R total is equal to V divided by EMF. You could also do that here. I could write XZ divided by XY. The length of the part that I'm interested in divided by the total length. Same thing. This is the whole thing is potential divider because you know that R is equal to rho L by A. So if all other things are constant like rho and A, R is proportional to L. Okay. So we can actually write that the length of xz divided by the total length is actually equal to how much voltage is it getting? It's getting 5.4 according to my diagram, and the total EMF is 9 volts. So 5.4 by 9 into 1.2 gives us a value of 0.72. So the length of xz is 0.72 meters. That is how it's done using this expression that I taught you over here. Okay, fine. The environmental conditions change, causing a decrease in the resistance of the LDR. The temperature of the LDR remains constant. State whether there is a decrease, increase, or no change to the intensity of the light illuminating the LDR. So we know that for an LDR, it's an NTC made up of semiconductor. So it behaves differently compared to a typical resistor. If light intensity increases, resistance will decrease, and if light intensity decreases, resistance will increase. So since there is a decrease in the resistance of the LDR, decrease in resistance, what happened to the light intensity? Clearly it increased. Okay, so that's our first point. The light intensity increases. Now let's go to the next part. Next part says the total power produced by the battery. So let's take a look at the battery over here. Since the total resistance decreased in the circuit, in which circuit basically? Anyone. If total resistance decreases, what will happen to current? Current increases, and you know that, okay, so for part 2, resistance decreases, so current must increase. Now, we know that power produced by battery, the formula is P is equal to power produced by battery, EI, where E is the EMF and I is the current. So if current increases, then power produced by the battery must also increase. So it will be power increases, really important. Next one, the length exits so that the galvanometer reads 0. So here's the thing. As you reduce the resistance of this thing from 1800 to 1600 or 1700 maybe, to keep things in place, to keep the galvanometer in place, what you need to do is you need to actually shift this movable junction to somewhere to the left basically, because now the left side has, you know, less resistance, so it won't be 5.4 volts anymore. Maybe it will be something like 4.8, and in that case this is going to be 4.2. So the Z or the point needs to be moved closer to X because this one has a lower resistance, so it has lower voltage, so we need to move it closer. so that this part is longer so that it balances out this greater voltage, and this part is shorter. Okay, so that's what they asked. The length xz, so the galvanometer reads 0. So we have to say that the length xz, this is the hard part actually, the length xz must decrease. Okay, oh, we just had to say increase, increase, decrease. Fine. So I want to explain this again. Due to a decrease in resistance, this has the same resistance, right? Due to its decrease, it will take a lower voltage compared to this guy over here, compared to the previous state. Now, this one has a higher voltage while this one has lower. To keep the galvanometer still balanced at the zero fluctuation, you know, this length over here, ZY, has to be longer now. How? By moving the movable junction to the left. Because if it stayed in its normal position, there would be an imbalance. Why? Because this would still be, you know, 3.6 while this would be 4.2, but that can't happen. I need to ensure that both of them are equally distributed. Like if the one below is 4.2, the one above must also be 4.2. How? By increasing the length of that side, and this must decrease to a smaller length. Okay, see if that makes sense. Hard sum over here. Anyway, moving on to the last question of the day, question number 8. My favorite question actually, because it takes so less time. Nucleus P and nucleus Q are isotopes of the same element, so they have the same number of protons. So the number of protons, the number of protons are the same, or you could just say that they are equal. Then the number of neutrons. So for isotopes, they have same proton number but different mass number, so different neutron number as well. Okay, this will be different. When nucleus Q decays to form nucleus R, the quark composition of a nucleon changes. Change the quark composition of the nucleon. So Q is unstable. Q is unstable and emits a beta minus particle to form R. And also, since it's beta minus decay, it's going to form an electron antineutrino. So that is 0 minus 1. So maybe if this was 14 and 7, this will basically turn into 8. 8 minus 1 is 7, and it still remains at 14, right? Like this. So what happened actually? We gained a proton and lost a neutron. So a neutron was converted to a proton, or UDD was converted to UUD, or more simply, D was converted to U. Okay? So you can answer it in multiple ways, but the basic one is the down quark D changes to down quark changes to up quark. Or you could say that up down down changes to up up down. Okay, state the name of another particle that must be emitted from nucleus Q. Another lepton is released, which is called an electron antineutrino. The electron antineutrino is released. Remember, in beta minus decay, electron antineutrino is released, but in beta plus decay, electron neutrino is released. Now, a hadron consists of 2 charm quarks and 1 bottom. So let's talk about the family of particles. We have leptons and hadrons. Okay, now about hadrons, what are they exactly? Hadrons are particles which actually feel the strong nuclear force, while leptons don't. Hadrons are of 2 types, baryons and mesons. Baryons are made up of 3 quarks, another fundamental particle, while mesons are made up of 2. And in a meson, you need a normal quark and another antiquark. It doesn't have to be its antiquark specifically. So a hadron consists of 2 charm quarks and 1 bottom. Okay, let's find this out. We know that the quarks are, this is the charge and the quark name. Up, down, top, bottom, strange, and charm. So plus 2 by 3 minus 1 by 3e, plus 2 by 3 minus 1 by 3e, plus Oh, strange is, sorry, I messed up the order. Strange is also minus 1 by 3, and charm is plus 2 by 3. Fine. So let's find out the charge. So I wrote it in the right, but let's still write down that charm is basically plus 2 by 3, and the bottom quark, remember the bottom and down are minus 1 by 3, and strange is also minus 1 by 3. Okay, so finally the net charge is going to be plus 2 by 3e plus 2 by 3e minus 1 by 3e. Okay, so 2 by 3 into 2 minus 1 by 3, which gives you a value of plus 1e. So that's plus 1e. Fine, you need to mention the plus sign. It's better if you do. Alright guys, that has been it for this video. Overall, I wouldn't call it that easy, honestly. Like, there were places where you could make mistakes. I don't know why the threshold was so high. Yeah, maybe you guys are just that good, the people who gave the exam in May June 2023. A lot of my students gave the exam. They're pretty good, it seems. But yeah, overall, I hope it helped you guys, the ones who are giving the exam in May June 2024 session or ON 2023. And as usual, please do smash that like button if you love the content. Remember to subscribe to the channel. Also, consider supporting me on Patreon. And quick shout out to my patrons before I end the video for this month, the highest tier patrons. So for this month, we have Dewa, Luna, and Sean supporting me. So consider supporting me on Patreon of the highest tier to have your name featured on the end screen as well. Also, we're hitting 10,000 subs this week. We've already hit 10,000 subs by the time this video is up. Hopefully, fingers crossed. And love you guys for the support. Please keep on continuing it. And yeah, hopefully I can bring out more videos for you guys. So I'll link the paper for 9702. May June 2023 paper 2-1 up here, and the paper for May June 2023 variant 2-3 down here, and the playlist for physics paper 2 up here. And remember to hit the subscribe button. See you guys. Bye bye.